Hello, students. This is Miss Tracy, and I wanted to give you guys a little tutorial video about our semester exam and review all of the problems. And we're going to do these in the order in which most people needed help. So I'm going to start with the problem that the fewest number of people passed or got correct, and then work my way up until the one that the most number of people got correct. So once we get to all of your problems that you didn't get correct, that you can now see how to work the right way, then you can stop watching, because chances are you'll more than likely have them all by then. Okay. But I want to address the ones that hit the majority first and then work my way from there, if that makes sense. All right. That being said, let's jump into the first problem. So this was the first problem, the ideal gas problem. And where most of you messed up was with this unit of measure, newtons per square meter. Now, those of you who got the right number and put Newton meter square, I gave you half credit so that, you were trying and you knew you were supposed to use that. But what it was supposed to be was newtons per meter square, just like it's written here. We know the fraction bar means per, just like in a ratio. So newtons per square meter is written like this, not like this. This is not the right unit of measure, and that matters. It matters. So if you had written it like this, I gave you full credit. If you wrote it like this, I only gave you half credit because you didn't get the unit of measure right. But you did get the right number. Now, some of you had this and a completely wrong number. You got the whole thing wrong. I'm sorry. A few of you got it 100% and used this measure. Some of you were smart enough to ask me or Miss Anna, hey, how does that supposed to look? And if you asked, I helped you. I showed you what it should have been. And, you have to ask because sometimes it's confusing. And something like this, I don't mind helping you on because I didn't actually tell you how to solve the problem. I just help you clarify the format. I don't have a problem with that. That being said, let's jump into the problem specifically and see how it works. So 16 liters of an ideal gas. This immediately tells me my volume, and it is a gas problem, so it's going to be in the format of P1 V1 over T1 equals P2 V2 over T2. It's one of these, right? So the next thing I see is there's a temperature here. There's my temperature, my initial temperature, and then my initial pressure, okay? Then I have a new volume. Actually, I'm going to switch colors here. Let's go to green. I have a new volume, and I have a new temperature. So now I know how to set up my problem. 16 liters of an ideal gas. So that's my original volume, and my original pressure is 100. My original temperature, Kelvin, is a temperature, so 500 goes here. Now, my volume is increased to 20. We're looking for the pressure, so P2 is what I'm looking for. My volume is 20, and my temperature is 400. So now I can solve. So that would be 1600 over 500. And that would equal 20 P squared over 400. I can cross multiply if I want, or I can reduce if I want. So if I reduced this, then I would have 32. Is that right? 3.2? I think so. Let's just do the math right quick. 1600 divided by 500. 3.2. So you could do 3.2 on this side is equal to 20 divided by 400 is 0.05p squared. Divide both sides by 0.05. 3.2 I didn't do right, did it? 3.2 divided by 0.05 would be 64. 64 is the new pressure, and that pressure is in newtons per square meter, so 64 newtons per meter square. You could also solve it this way. You could also cross multiply. So if you cross multiplied, you would get 1600 times 400, which would be 640,000, equal to 10,000p set to the second. 640,000 divided by 10,000 is 64, and that would still be 64 newtons per meters square. So you get the same answer either way you did it, all right? You're probably used to solving it like this. It takes just about the same amount of effort to solve it like this. So whichever way you wanted to do it worked. All right, the math is true for both methods. As long as you're doing the math correctly and the process correctly, right, what it tells you to do in the right way, you're going to get the right answer. All right, this was the one most of you got wrong. Now, if you go back and look at your exam, I've already regraded everything. And if, like I said, if you got close, I gave you half credit. If you got this number right, that means you know how to work the problem and you just had the unit of measure incorrect. Pay attention to the word problems. Pay attention to the words. We communicate our problems in life via language. We speak to one another. And when I say something like this, newtons per square meter, or cubic cups, or whatever it might be. I don't know. You've got to be able to listen to someone and understand what they're saying. And part of that is being able to read a word problem and decipher what has to be done. And what the unit of measure is part of that. So the details matter is all I'm trying to say. Let's move on to the next problem. By the way, if you're curious, only 13% of you got this one correct. So let's move on to the next problem. All right, this problem, only 25% of you got it correct. So 1 out of 4 people got this one right. So let's convert 30 feet per second to meters per hour. So 30, and then we've got feet per 1 second. Let's get rid of the unit of measure first, the length. Then we're going to approach that. So we're going to convert this to meters, from feet to meters first. So we're going to go from feet to inches. So 12 inches is 1 foot. And then 2.54 centimeters is 1 inch. And then 1 meter is 100 centimeters. All right, now we are in meters. So now we can address the time. So let's address the time. We go from seconds to minutes. So 60 seconds is 1 minute. And 60 minutes is 1 hour. An hour is where we wanted to go, from seconds to hours. Now, all we have to do is write down the whole numbers aside from 1, that, because 1 doesn't mean anything, as a factor. It just restates the other numbers. So we have 30 times 12 times 2.54 times 60 twice, all over. The only number down here is 100. And this is in meters, and this is in hours. And that is the way you would write it. That would be your answer. All right, let's look at the next one. So this problem, number 11, says to find y, and this is y right here. Now, in order to find y, you've got to know what this arc is, and it tells you it's 100, and you've got to know what this arc is. And we know that a circle is a full 360 degrees, right? 360 degrees, and of that 360 degrees, all of the circle is enclosed in this angle as a minor and major arc, except for this 90 degrees down here in the bottom. It is outside of the angle. So we get rid of that. We get rid of that 90 degrees, and we're left with 270 degrees of the circle being used, right? So of that, we know that we need to subtract. In order to find y, we've got to subtract the major arc minus the minor arc is going to give us the value of y. So in order to find the length of or the degree of the major arc, we've got to subtract this minor arc from it because they're both added together right now. Right now we have that the major plus the minor is equal to 270. So we're going to subtract the major minus, actually what I should say is the major plus 100 is equal to 270. So if we subtract 100 from both sides, the major arc is 170 degrees. Now we know how to fill this in. Major arc is 170 minus the minor arc, which is 100. That's going to give us, I'm sorry, that should be y divided by 2. That's going to give us 70 divided by 2, which equals 35. So y is equal to 35 degrees. That's the value of y. Okay, I wrote that entirely wrong. Should have said y is equal to the major arc minus the minor arc divided by 2, which would have been 170 minus 100 divided by 2. Y is equal to 70 divided by 2, which is equal to 35. All right, that's a better explanation. That's written correctly. So it matters where you divide, right? It matters how this is written. But that's how we find the angle on the outside of a circle. Okay, when you have two chords, even if one of those chords is tangent, that point where they touch to right over here where it crosses again, that is this minor arc, right? That is the minor arc. This is the minor. And where it touches here to where it touches here, this is the major arc. The bigger arc is the major arc, and it's usually the one opposite the angle. So not on the same side as the angle, it's on the other side from the angle. That's usually the way it works. So that's how you do. You subtract when the angle is on the outside. And you still divide by 2. Okay? All right, next problem. And by the way, 31% got this correct. So 1 out of 3, roughly. All right, so for this problem, some of you got partial credit because it was a formatting error. Some of you, I don't know what the heck you were doing. I'm just gonna be real. 31% of you got this correct. So about 1 out of 3. So here we've got, let me change the color here. Here we've got a rectangle in the middle and a half circle here and a half circle here. Well, guess what? They have exactly the same diameter because they're on the end of, or they're on opposite ends of the same rectangle. So they have the same height. So if the height here is 8, the height here is 8. That means it has a diameter of 8. Well, a radius is half the diameter. So that means the radius here is 4. Right? Our rectangle is 8 by 15. We have a rectangle that is 8 by 15. So the area of that rectangle is 8 feet by 15 feet. Pretty straightforward. And if we do the calculation on that, we have 8 times 15 is 120. 120 feet squared. That's the area of this rectangle. Well, if we have a half a circle here and a half a circle here with exactly the same diameter, it'll have exactly the same radius. That means a half and a half equals 1 whole circle. So we have 1 whole circle. We don't have to divide anything by 2. So we have the area of a circle. We know that's pi r squared. So pi times 4 feet times 4 feet, because that is the radius based on the diameter being 8. Radius is half of that. So pi r squared. Excuse me. So this is going to be 16 pi feet squared. This is our area. We're going to add it together. They're not like terms. So we're going to say feet squared for everything, but then we're going to put it in parentheses. 120 plus 16 pi. Okay, there's our area. Now we have to find the volume. 8 feet high. That is our height. So we are going to take this and multiply it by 8 feet. All of these are factors. We're multiplying all of the factors together. So I can just start with the unit of measure if I want to. Feet times feet squared is going to be feet cubed. And 8 times 120 is going to be 960. Because I know that 8 times 12 is 96. And I just slap a 0 on the end of it. 8 times 16. Well, 8 times 10 is 80. And 8 times 6 is 48. That's 128. So 128 pi. This is your answer. 960 plus 128 pi, all feet cubed. Now, if you did not put the parenthesis, you had points deducted, because not putting that parenthesis on there means that the only thing that is in feet cubed is the last term. So if you write it like this, this is only applied to here. In order to distribute, remember the distribution polity, the distributive property, you have to do this to be able to multiply this unit of measure times this and this term. The details matter. Pay attention to the details. If you slap this up there for your professor when you get to college, guess what? He's not even going to tell you why it's wrong. He's just going to mark it wrong. I'm telling you why now, so you won't make that mistake later. You have to use the parenthesis in order to distribute the unit of measure to both of these. Okay? All right. And that's the way we answer it. Next problem. All right, so this one 44% of you got right. So very good. So that means a little over 4 out of 6 people, or 4 out of 10 people got this right. So we're getting better at going further to the ones that more people have gotten correct. So we're getting closer to the end, is my point. All right, so let's look at this problem. We had to find x. So we really have 2 triangles here. And in order to really see them, I like to redraw my triangle so I can give it, a better illustration. So I have 3, I have x. I don't know what this is here, right? I don't know what this is. I don't know that we need to know, right? We only need to know what x is. So we're just going to do this bigger triangle, which is 3 plus 3 on the bottom, so that's 6, and this is 4. And I still don't know what this is, right? So what I can do, though, is I can create a scale factor between these 2 triangles, these 2 bases, and I can say 3 times, we'll call this A, we'll call this B, 3 times some scale factor. Let me rewrite that as a formula. A times some scale factor is going to give me the dimension of B, right? Because they are similar triangles. We know that because we have the same angle here and here. This is the same angle here and here. So that means that this third angle has to be the same here and here, right? So these are similar triangles. So scale factor works. So if I drop in the numbers for A and B, on A, the base is 3 times some scale factor is equal to the base of B, which is 6. So 3 times some scale factor, if I divide both sides by 3, my scale factor is going to equal 2. So now I can apply this to this side right here, right? I don't know. I know that A times the scale factor of 2 is equal to B. That's going to be my formula. Well, I don't know what A is, so A remains a mystery. This A, we'll call it Y. Let's just call it Y for now instead of A. It is the upright dimension Y on triangle A. Y times 2 is equal to 4. If I divide both sides by 2, which is my known factor here, Y is equal to 2. So this Y is 2. Now I can find x, because now all I have to do is Pythagorean's theorem. So 3 squared plus 2 squared is equal to x squared. 9 plus 4 is equal to x squared. And that's going to be 13 is equal to x squared. If I take the square root of both sides, that cancels that. So the square root of 13 is the length of x. And that would be the answer you want to type in, square root of 13. All right, let's look at the next problem. So 56% of you got this problem right. I'm so proud, more than half. That means 9 of you when it comes down to it. So good job. Y'all are understanding this, it seems like most of you, at least half of you are, or over half of you are. So let's convert this to rectangular form. So first we have to know what this means. 8 is your hypotenuse, it's your length, and 310 degrees, it's where it's located in the Cartesian coordinate system. And we know we start counting here in degrees. First quadrant, that's 90 degrees. Second quadrant, that's another 90 degrees. So from here to here is 90, and then from here all the way around to here is 180. So from here all the way around again, add another 90, that's going to be 270 at this axis. So from 270 to here would be 360. So that 310 lives somewhere in here. We have to find out where. So 310 minus 270 is equal to 40 degrees. So at the 40 degree mark, from here to here, 40 degrees, about right there maybe, ish, that's our vector. And this line is the hypotenuse. It's 8 whatever long. So we create a right angle to the x-axis. It's always to the x-axis. Here's our right angle. And if this is 40 degrees and this whole thing is 90, 90 minus 40 is equal to 50. So this angle to the x-axis is going to be 50 degrees. Okay. Now in rectangular form, the x-axis is r and the y-axis is u, but it's below the x-axis, so this is on the negative side of the y-axis, so it's going to be a negative u. Okay. So we have to find the opposite and the adjacent side of this right triangle with a hypotenuse of 8 and a 50-degree angle. So we're going to say 8 times the cosine of 50 degrees is equal to, and because it's so toa, right? Cosine is adjacent, so that's r. That'd be a positive r. And 8 times the sine is O, so that's the opposite, so that's going to be negative u. So all we have to do is pull up our calculator. So let's pull that up, and we are going to just type it in. So I'm going to find 50 cosine times 8 equals 5.14. I'm going to round it to 2 decimal places because that's what we like to use. 5.14 equals r. So let's find u. Clear this. 50 sine times 8. 6.128, this would round that to 6.13. So 6.13 equals negative u. We don't like u to be negative, so we multiply everything on both sides by a negative 1. Negative 6.13 equals u. And I wrote 14 for some unknown reason. Should have been a 3. Now we can put them together to find the rectangular forms. That'd be 5.14r minus 6.13u, and that is your answer. And that is all there is to it. All right, moving on to the next problem. All right, so this problem was another 56%er. 56% of you, over half of you got it right. So here's the way we would write these problems. Remember, when we convert them to an exponent, when we simplify them, we're going to put parentheses in place of the radical sign, and the index becomes the denominator. So we have m to the third, a to the fifth, written once with an index of 4, times m to the fifth, a to the fourth, written once with an index of 3. Now we just multiply the exponents. So 1/4 times 3 is going to be m and 3 over 4. A to the fifth, 5 times 1/4 is just going to be 5 over 4. All right, 1/3 times 5 is going to be m and 5 over 3. And then 4 times 1/3 is 4 over 3. Easy peasy. Now we just have to find a common denominator, and that common denominator is going to be 12. So we're just going to multiply by the opposite denominator and get 12s all the way across. So this becomes m. 3 times 3 is 9 over 12. 3 times this would be 15 over 12. 4 times this would be 20 over 12. And 4 times this would be 16 over 12. Now we just add the bases, the like terms of the bases together. So we have m, and we have 9 and 20 over 12. So this could be 29 over 12. And then for A, we have 15 and 16. That's going to be 31 over 12. That's it. That is your answer. And you could have written it in alphabetical order and put the A first, and I would have marked it right. That's all there is to it, ladies and gentlemen. Swap the parenthesis for the radical sign, right? Whatever's under the radical sign, you put that in the parenthesis. It's written one time, and then the index goes in the denominator. Then you multiply the exponents, find the common denominator if necessary, and combine, just like you would any other exponent and base. All right, next problem. All right, 63% of you, that means 10 people, got this one correct. So this is for the other part of the class that needs a little help. Now remember, I means the square root of -1. So when we have I squared, that equals -1. And if we have I to the 4th power, we have -1 times -1, which just equals 1, right? So those are some things that you're going to want to write down. Make sure you have that in, like, on the back of your notebook cover for easy reference. So whenever you see them, you know how to handle them. So we would just look for those things and drop them in. So we have 4 times a -1, that's a -4, minus square root of 16. We take the negative sign out and make it an I, because then that would be times the -1, square root of -1, that's I, plus 3 times the square root of 9, I, minus 4 plus 7, because square root of 49 is 7. 7 times 7 is 49. Now we can deal with these square roots. -4 minus 4i plus, we have 3, and this is going to be 3. So 3 times 3, that's 9i minus 4 plus 7. So let's add like terms. We have a -4 and a -4. That's going to be a -8 plus 7. And then we have a -4 and a +9. That's going to be plus 5i. So that's going to be a -1 plus 5i. It has to be written like this, because when we are dealing with imaginary numbers, that's what that I stands for. It's imaginary. It has to come second. It has to be written in the format A plus BI. And the A and the B are coefficients. This is a whole number, possibly with variables. This is the number or the coefficient that goes with the I term, and it's always written second. If it is not in this format, it's not right. And I'm sorry if you got the right number and you put in, if you wrote 5i minus 1, it's not right. It's not right. I'm sorry, but it's not. The form matters. It matters on purpose. You have to put it like this or it gets marked wrong. I'm so sorry, but that's just mathematics. That is the way it has to work. So some of you missed it because you didn't put it in the right form, not because you didn't understand I or I squared. So think about that in the future. The form of it matters. That's one thing that I found that we as homeschoolers tend to get a little sloppy on is format. But if you want to be right, you have to do it right. And format is a part of that. It's not just getting the right number. It has to be in the right context or the right form. So be careful. Pay attention when your teacher says it has to be in this style or this format or this order. It makes a difference because those things will be on the ACT. Pay attention. Next problem. So 69% of you all, that means 11 students, got this problem correct. So good job. Y'all are doing well. But let's look at it and see what we can do to solve it. So we know when we have a radical, we can change that by squaring it. But we have to get it to where that's the only thing on that side in order to make it work. So we're going to subtract 6 from both sides so we can keep the equal sign true, but then so we can get this isolated. So then we would have the square root of x squared minus 8x plus 3 equal to x minus 6. So then we would square both sides, and we would have x squared minus 8x plus 3 is equal to, and I'm going to rewrite this x minus 6 just for the sake of seeing it, and I'm doing it all in my head. So that would be x squared. This would be negative 6x, negative 6x, positive 36. So we would have x squared minus 8x plus 3 equals x squared minus 12x plus 36. So let's combine our like terms. Let's bring all of these over here. So minus x squared plus 12x minus 36. Just the opposite. Minus x squared plus 12x minus 36. So these all cancel. So this would cancel. We would have 4x minus 33 is equal to 0. All right, does everybody see where we are? All right, so now our next step is to solve for x. So we're going to take this 33 and add it back to both sides. So plus 33 gives us 4x is equal to 33. So then we can, let me scroll this up a little bit, divide both sides by 4. X is equal to 33 over 4. That's our answer. Now we're going to check that answer and see if it works. So let's drop that in. So we got square root of 33 over 4 squared minus 8 times 33 over 4 plus 3 plus 6 equals 33 over 4. So we're going to solve this kind of the same way, just to, well, I guess we could wait. Let's just do this and see what we can get. So let's do 33 times 33 equals 1089. So 1089 over 16 minus 8 times 33 is 264 over 4 plus 3. All right, so let's see if we can divide 264 by 4. 66, all right, so that's 66 plus 3. It's a negative 66 plus 3. Let's see if we can divide this. 1089 divided by 16. Not quite, but I bet we can reduce it. 1089 divided by 4. Nope, not quite there. So we're going to have to redo this. And we're going to have to put this in a different format. So this is going to be 1089 over 16 minus, we're going to multiply this by 4. So it's going to be 264 times 4 is 1056 over 16 plus 16 times 3. That's going to be 48. Yeah, 48 over 16. That's square root of all of that. So now we can actually do the math here. So let's do that. So 1089 minus 1056 plus 48 is 81 divided by 16. So 81 over 16 square root of. And that's plus 6 is equal to 33 over 4. So we know we can split this up and say square root of 81 over square root of 16 plus 6. Let me get some more room over here. Is equal to 33 over 4. That would be 9 over 4 plus 6. If I multiply this and get a common denominator here, 4 times 6 is 24 over 4. Guess what? 9 plus 24 is 33 over 4, which is equal to 33 over 4. So yes, this is the correct solution because it does check out. Sometimes you're going to do these problems and you check them and they don't equal. They don't come out right. So then it's no solution. This one, however, does have a correct solution, 33 over 4. So that was this one if you need to recognize it. Next problem. So here we have another 69%er. The carbon in a container of this weighs 936 grams. How much does the chlorine in the container weigh? So it's telling us how much by giving us the carbon value. So first of all, let's get the total value of this right here. So we've got C, we've got H, we've got N, and we've got Cl as our components. C is equal to 12, H is equal to 1, N is equal to 14, and Cl is equal to 35. Now looking at our recipe here, C is 6, so times 6. H, there's 8 of those, so times 8. There's 1 N and there's 1 Cl. We know there's 1 because there's not a number listed. There's not a number listed, then there's only one of them. Okay, its very presence means 1. So this is going to be our weight here. 12 times 6, that's 72. 1 times 8 is 8. That's 14, and this is 35. All right, so we have got to add these together to get our total weight of the solution. So that's 10, 14, 19, carry 1, 8, 9, 12. 129 grams in one unit of this solution. That's how much it weighs. Now we're told that we've got carbon equaling 936 grams in another quantity. So that's 936 that I did not write correctly. So 936, this is our quantity, right? So we've got to figure out the ratio here. So we've got to find the total amount. This is our total amount. So we've got to find out the total amount. We've got to find out the scale factor that's going on. So we're going to put in X right here. So we set this up as our proportion. 72 over 129 should equal some 936 scaled version of that, 936 over X. So 72X is equal to 129 times 936, which would be 120,744. So 120,744 is 72x. Divide both sides by 72. And x is equal to 1,677. That's how many grams in this total solution. Now we can write a new proportion statement for the chlorine using the chlorine's weight. 35 over 129, because that's how much chlorine is in this original composition, is equal to, now we have the total weight for the new composition, which is 1677, and we're going to find the amount of chlorine that we have. So we cross multiply. So times 35, and that's going to be 58,695 is equal to 129x. Divide both sides by 129, and x is going to be equal to 455. So 455 grams of chlorine is in the new solution that has 1,677 grams total in it. We still don't know how much in is hydrogen or sodium. Well, that's not sodium. What is N? I don't know what N is. This is hydrogen, and this is something else, whatever it might be. But we don't know how much is in H and N. But we do know how much we have carbon and chlorine in this new amount of this total solution. And that was number 4. Let's look at the next problem. All right, this is another 69%. Means 11 of you got this one right. This just said to solve, so we're solving for x. So we're going to find a common denominator here of 6, and because it's an equation, we can eliminate it once we find it. So we're going to multiply this by 3. So 3 times 5x minus 2 over 6 minus 2 times x plus 3 over 6 is equal to 12 over 6. So that means we can eliminate that denominator, and we have 15x minus 6 minus 2x minus 6 is equal to 12. So we have 13x is equal to 0. So x is equal to 0. So let's see if that's right. Okay, that's not right. I see where I went wrong. So whenever I mentally made that jump, I looked at, for just a second, I'm like, that is not right. That can't be right. I took these negative 12s and looked at this positive 12 and canceled it, but that's not what you would do. You would add these together. You would get 13x minus 12. That is why it's so important to write down each step and not do stuff in your head and skip it, because you might make a mistake like this. I should have added 12 to both sides. And those of you in the 69% that got that knew what I was doing and were like, oh, Miss Tracy's doing it wrong. So then that would be 24. So when we divide both sides by 13, x is equal to 24 over 13. And then that would be your response. That would be your answer. And because there's not a radical sign, we don't really have to check it. And, you can, and I recommend that you do, but you don't have to go all the way back to here. You can go in here and drop it in and check it, and it should be correct. So 24 over 13 is the right answer. Let's look at the next one. All right, this is the last 69%er. So this is a set of fraction divided by fraction. So we're going to keep it, change it, flip it right away. Before we keep it, change it, flip it, we're going to do a little factoring. We'll factor and then we'll flip when we factor the next one. How about that? So I can factor a p and a q out of every single one of these. So let's do that. P times q times x squared minus 2x minus 15 over, and that is a really bad fraction bar, or vinculum. If you don't know what a fraction bar is called, it's a vinculum. And we're going to rewrite this in the right order. This is x squared minus 3x minus 18. Now, whenever we keep it, change it, flip it, we would change the sign, and then we're going to flip, right? So we're going to rewrite this in the proper order. X squared minus 5x minus 6. And I'm going to factor out p and q from each one of these. P, q, And then this is going to be positive x squared minus 1x minus 20. Now we can factor these more appropriately. And the first thing I'm going to do is I'm going to factor out my PQ, just like that. Those are gone. We don't have to deal with any P's and any Q's. Now we can factor these just the way they are. So binomials, if you please, top and bottom. Now we know, because these are all x squared, x, 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 x in all of them. All right, let's look at the first one. We have 15. We need to have a negative 2 remaining to multiply 15. We know the only factors of 15 are 5 and 3. And in order to have a negative 2, we have to have a negative 5 and a positive 3. For 18, we know that we have 2 times 9 is 18, and 3 times 6 is 18. So in order to have a negative 3, we need to have a negative 6, positive 3. Well, guess what I see? I see 2 factors that cancel each other out. So now let's look over here. We have negative 6. In order to get a negative 6 and have a negative 5 remaining, we've got to have a minus 6 times a positive 1, which would give us negative 6x, positive 1x, which gives us negative 5x. So x minus 6 factor cancels this x minus 6 factor. How about that? So now let's look down here at the bottom. We have 2 digits that the 2 factors that would leave a negative 1 behind. It'd be 4 times 5. The difference is 1. But the 5 is the one that has to be negative because we need it to be the larger number. So that would be the one that's left. Plus 4. So the x minus 5 would cancel each other out. So that means our response, our final response, is x plus 1 over x plus 4. Easy peasy. Lemon squeezy. All right, let's move on. This was the last 69%er. So we're getting into the area where the majority of you know what you're doing, over 70% for the next part. So if you've gotten all the problems solved that you missed, you don't have to watch anymore. That's awesome. But if you still have a few problems that you need to watch, then these are for you. All right, so this is a 75%er, which equates to 12 students getting correct. So whenever you have the radical, remember I said before, you treat it like a parenthesis. Well, you always go to the innermost, whenever we do PEMDAS, we go to the innermost parenthesis first. You go to the innermost radical also. So we put that in here. We put that 3, and then it's written once, and there is no index written, so it's by default a 2. Now we have a 27 here. We can't use 27. We need the bases to be the same in order to have that relationship. So we're going to rewrite this with an exponent. So that's going to be 3 cubed, which is 27. So 27 is written once here, but it has an index of 5. Now we can multiply. So 1/5 times 3 is going to be 3 and 3/5. And then we're going to multiply 1/5 times 1/2, that's 1/10. So 3 and 1/10. So if we double this, that'd be 3 and 6/10. We would have the same denominator. So we add them together and we get 3 and 7/10, and that is the right answer. So let's look at the next ones. All right, so here we have an internal angle that we're trying to solve. Now we're told whenever we have an internal angle that we add. Remember when we had the external angle earlier, we had to find that angle, we had to subtract. Now we're going to add. So we're told what both of these are, right? 110 plus 90, that equals 200. We're going to divide that by 2, and that is going to be the value of y. So 200 over 2, that's 100 degrees for y, and that is the answer, 100. Easy peasy. All right, so now we're stepping into the 81%, which means 13 students got this correct. So we have to complete the square here. All right, so what we're going to do is we're going to take this middle term. Well, first, we're going to divide everything by the lead exponent. So divided by 3 on each one of these. So we get x squared plus 2/3 x is equal to 10 over 3. So there's that. That's what we start with. Now we're going to take this term here, this x term, and we are going to divide it by 2, which means we're going to multiply it by 1/2. And that's going to equal 2 over 6. And then we're going to square that, which is going to equal 4 over 36, right? Now we're going to take this and we're going to add it to both sides. X squared plus 2/3 x plus 4 over 36 is equal to 10 over 3 plus 4 over 36. We're going to put this in the same denominator so that it's going to we can add them together. All right, so if I multiply this by 12, because the factors of 36 are 3 and 12, then this is going to be in the right denominator. So I'm going to go ahead and do that. 10 times 12 is 120, and 12 times 3 is 36. So now I can add them together. So x squared plus 2/3 x plus 4 over 36 is equal to 124 over 36. Now I can factor, and I get that x plus 2 over 6 squared is equal to 124 over 36. So I'm going to unsquare this side, and I'm going to unsquare this side. And when I do that, this cancels. And now I have x plus 2 over 6 is equal to the square root of 124 over the square root of 36, right? X plus 2 over 6 is equal to square root of 36 is going to be, well, actually this is plus or minus, sorry, 6, so that's going to be the square root of 124. So I bet I can factor some things out of here. So square root of 2 times that would be 62. I know it can get 2 again, so that would be 4 times 31, right? Which would be 2. So this is going to be 2 times the square root of 31. Well, guess what? We can reduce everything. Let's subtract this and say x is equal to negative 2 over 6 plus or minus 2 times the square root of 31 over 6. We can reduce both of those to x is equal negative 1/3 plus or minus square root of 31 over 3. That's your answer. And this is the way you want to write it. You want to write it in separate terms whenever there's a radical. It's not wrong if you put them together like this. It's just not the accepted format. So you do want to separate whenever there's a radical and put them in different terms, okay? Because you're doing plus or minus, so you need to have that distinction here, okay? So this is your answer, all right? So good job on y'all for most of you getting it correct. That's pretty awesome. Let's do the next one. All right, so here's another 81%er. 13 of y'all got this right. So we need to simplify this. So what we need to do is keep it, change it, flip it. But first we need to have one fraction over one fraction. So we're going to get a common denominator and combine these. So we're going to multiply by the opposite denominator, and that'll straighten all of that out. So we've got b squared times bc minus em squared over mb squared all over 4b squared m minus, I'm sorry, that would not be 4b squared m because b squared is already here. That'd be 4m minus bc over b squared m. Because this has everything in it, we just needed the m over here. Now we can keep it, change it, flip it. So we've got b cubed c minus em squared over mb squared times b squared m over 4m minus bc. All right, do you see how mb squared and b squared m, those are the same terms, so we can cancel those out entirely. All right, so what we have here is going to be b cubed c minus em squared all over 4m minus bc. And that is the way we should write it, just like that. All right, moving on. All right, 88%. That means 14 of y'all got this right. Good job. Very good job. So we're going to rewrite this in the way that we need to in order to solve for this negative 16 minus the 5 to the 4th. So we're going to put the index. This is a negative. We got an index of 4. And then we've got 16 to the negative 5. Right? So it's going to be negative 4, 1 over 16 to the 5th power. All right, you with me so far? So then we're going to take care of this, right? Negative 4th root 1 over 16 to the 5th power. That's going to be 16 5th power. Now let's see what the 4th root of that is. 32. Okay, so when we take that out, I'm going to put that back in a 4th power. 1,048,567. All right, we rewrite that as negative 4th root of 1, 4th root of 1,048,567, right? 4th root of 1 is still 1, so that's going to equal a negative 1 over, and then 4th root of this is 32. This is your answer, negative 1 over 32. Here is another 88%er. We were supposed to solve this by graphing and then find the exact solution by either substitution or elimination. We're going to skip the graphing and just go ahead and do, let's do elimination because I see something I can easily do. So I'm going to multiply the bottom one by 2 as I write it down. So 2 times 3x is 6x. 2 times positive 2y is positive 4y. And 2 times the negative 1 is negative 2. So now this cancels, and I get 12x is equal to 12. So x is equal to 1. 12 divided by 12 is 1. So my first term, x is 1. So let's substitute in for this problem. 6x, which is 1, minus 4y is equal to 14. So 6 minus 4y is equal to 14. Subtract 6 from both sides. Negative 4y is equal to negative 20. Divide both sides by negative 4. Y is equal to 5. I don't think that's right. Let's look and see. That's not right. Let me see, what did I do wrong? So x is 1. So I should be able to sub that in. 6 minus 4y is equal to 14. Minus, oh, that's what I did. I wrote negative 14. That was my mistake. All right, that makes more sense. So I've got minus 4y. I'm sorry. Well, I forgot. Lost track of what I was doing. Subtract 6 from both sides. It was this being a positive made the whole difference. So this cancels. Negative 4y is equal to 14 minus 6 is 8. Both sides divided by negative 4. Y is equal to negative 2. So negative 2. And that is correct. 1, negative 2 should be your answer for this problem. And this was 88% of y'all got this right. So good job. All right, here's the last 88% problem. A chemist has one solution that is 25% salt and another solution that is 10% salt. How many liters of each should the chemist use to make 120 liters of a solution that is 15% salt? So first we have to write an equation that talks about making 120 liters of the solution. So we're going to say, let's say that 25% is going to be equal to the amount that we pour in, and that 10% is going to be equal to the amount that we dump in, right? Those are going to be our variables. So the amount that we pour in plus the amount that we dump in is going to give us a total of 120 liters. So there's our quantity equation. Now we're going to do a value equation where we apply the percentage to each one. So here's our percentage one. We've got 25%, which is 0.25 times P, plus 10%, which is the value of D, and 15%, which is the value of that final amount of 120. So in order to solve this, we're going to create a substitution value using our quantity equation. So I'm going to subtract D from both sides, and that's going to turn that into a substitution of P is equal to 120 minus D. So now I can substitute in for the value of P. And I'll put that in right here. So 0.25 times the value of P, which is 120 minus D, plus 0.10 times D is equal to 0.15 times 120. So now I can do just some quick calculations and solve for P. So 0.25 times 120, that's 30. So 30 minus 0.25 D plus 0.10 D is equal to, let's see what this is, 0.15 times 120 is 18. So that's 18. So I'm going to combine these and have a negative 0.15 D is equal to, and then I'm going to subtract 30 from both sides. So that's going to give me a negative 12. So now I can divide both sides by negative 0.15. And D is equal to, let's see, 12 divided by 0.15 is 80. and it's a positive 80 because a negative divided by negative is a positive number. So D is 10%, so that would be 10% here. Or I'm sorry, it already says 10%. The 10% solution, we would have 80 liters of 10%. So if we have 120 liters total, 120 minus 80 would give us 40 liters of the 25% solution. So that's what would go there. And it matters which one of these you put in there because the percentage is how much you would put of that percentage in there. But we do these just like we did the number of nickels, number of dimes, where we create a quantity value and then we our equation, and then we create a value equation that applies the value of each quantity to that term. All right, so that is the last 88%er. Let's look at some of the others. So 94% of you got this one correct. Very proud of you. That's 15 people of the 17 in the class. I think that's right. Let me see how many people are in the class. We have 16 people. Sorry. 16 people who took that. So we're going to find A. There it is. But that would be the answer that some of you would give me, and you know who you are. We're going to solve for A. So we're just going to multiply both sides by both denominators, right? To get rid of the denominator, because it's an equation, we can do that. So AP times X minus K over P minus AP times M equals AP times F over A, right? So the P's would cancel here. So we have AX minus KA, and then we have minus APM is equal to the A's cancel here, FP. All right, we're going to factor out the A's on this side. So A times X minus K minus PM is equal to FP. Divide both sides by X minus K minus PM. And A is equal to, because this cancels, FP, that's written in alphabetical order, X minus K minus, I'm going to put this in alphabetical order, MP. That would be your answer. We only have a few more, just like a couple more that are 97%. So this is our last one. I thought we had more than this. This is our last one. 97% of you got this right. And some of you got at least one of these right. And the reason it didn't mark the whole thing, the second one was where y'all messed up. So all of you got one set of these correct. 15 of you got the second set correct. And so there's only one person out there who didn't get this other three right. So I'm very proud that y'all are getting the hang of these and you've done a good job with that. So find 3 consecutive odd integers. That's my first clue, right? 3 consecutive odd integers. So that's going to look like n plus 2, n plus 4. Because when it's odd, it skips to get to the odd number. It skips over the even numbers. All right, so that is how we would write those expressions. Such that the product, so we're going to multiply of the second and third. So we're going to multiply the second times the third is, that's our equal sign, 55 less than. So we're going to subtract 55. 30 times the first. And the first is just n. So we're going to say 30n. Now we're just going to do some calculations and some distribution. That's n squared plus 2n plus 8 plus 4n. Yeah, so n squared 4n, 2n, 8. I kind of did that out of order, but I could see it in my head what I was doing. And that's 30n minus 55. I forgot my n. Okay, so let's combine these like terms. N squared plus 6n plus 8 is equal to 30n minus 55. So I am going to subtract 30n and add 55 to both sides. N squared minus 24 n plus 63 is equal to 0. All right, so I am looking at 63 here. And what can I multiply to get 63? Positive 63, that gives me a negative 24. Well, that's going to be n times n is equal to 0. 3 times 21 gives me 63. But if they're both negative, then I get a negative 24. So minus 3 minus 21. Negative 3 times a negative 21 gives me a positive 63, but a negative 3n and a negative 21n gives me a negative 24n. So these are my two possible roots. So n minus 3 equals 0. N is equal to a positive 3, or n minus 21 is equal to 0. N is equal to a positive 21. So we have two solutions here. So n is either 3 or 21, which means 5, 7, 23, 25. So that would be 3, 5, 7, or 21, 23, 25. And that would be how you would solve that problem. You have to take both roots. And there you go. That was the last problem for the semester exam. I hope you got what you needed in order to solve that. We only had one problem that was 100%. And I think I solved it for you earlier anyway, because I looked at the percent wrong and it thought it was like lower for some reason. But we had one that was 100%, and that was the one with the answer. That was 33 over 4. Everybody got that one right, so good job. All right, so I am excited. I hope that this helps you guys, because this semester exam is a recap of everything that you've learned this semester. So if you can understand the problems that we just did and wrap your head around how to solve them, then you'll be ready for next semester if you can understand what's been done. So take the time to figure out which problems you don't understand and ask for more explanation on why we did that the way we did that. Okay? And Miss Tracy out. Have a great Christmas break. I'll see you later.